Assalamualaikum and hi. Today my team and I will be presenting on non-destructive testing within petrochemical and shipbuilding industries. So to start, non-destructive testing or NDT is an inspection method to assess the integrity and reliability of a material and components without causing any damage. Unlike destructive testing, NDT allows components to remain in service after inspection. It is essential for quality assurance and safety in critical industries such as aerospace, automotive, power plants and oil and gas. By detecting and sizing defects early, NDT helps prevent failure throughout manufacturing and service life of a component. Now we have focused our study on two major sectors, which is petrochemical industry and shipbuilding industry. In petrochemical industry, we are dealing with massive systems like pipelines, pressure vessels, and storage tanks. These components operate under intense pressure, high temperature, and highly corrosive conditions. Because these environments are so harsh, the materials are naturally prone to degradation and wear over time. A failure in a pipeline or tanks isn't just a technical issue. It can lead to devastating fire, explosions, or environmental disaster. So that's why NDT is so critical because it allows us to monitor structural integrity and detect wall thinning without ever having to shut down the operations. In shipbuilding industry, we are looking at offshore structure that have to survive incredibly punishing marine environment. Ships are essentially giant welded steel structure, and the quality of those welds is everything because they have to withstand constant wave impacts and cargo movements. If a weld fails, you are looking at potential flooding or even a total structural collapse. We use NDT throughout the entire life of the ship, from the initial construction to routine maintenance, to ensure every weld meets strict marine safety standards.
We will start an overview about petrol, chemical and gas industry and shipbuilding sector. For petrochemical sector, this industry relies on systems like pipelines, pressure vessel and storage tank that handle oil and gas. These components operate under extreme pressure, high temperature and corrosive conditions. Critical risk of this petrochemical industry is harsh environment lead to material degradation and potential failure. Any structural failure can result in catastrophic events like leaks, fires, explosion, and environmental damage. So the role of NDT for this petrochemical and gas industry is to maintain safety. Non-destructive testing is used to detect corrosion and internal defect without interrupting operation. For the shipbuilding sector, ship and offshore structure must survive high impact waves and constant seawater corrosion. So welding integrity for the shipbuilding sector is ships are primarily welded steel structures. Because poor weld quality can lead to flooding or structural collapse. NDT is mandatory during construction and maintenance to ensure marine safety compliance. Next, while there are several ways to inspect material without damaging them, today we are highlighting two of the most methods used in the field, as you can see in this slide. First, ultrasonic testing, which is this method uses sound energy to see inside a material. As you can see in the image, it is highly portable and can be used directly on components like pipes. Next, radiographic testing. This is the second major method that used in NDT, which involves using radiation. It is similar to an X-ray to capture image of the internal structure of a pipe. Next, how ultrasonic testing works. The principle of ultrasonic that we send high frequency sound waves into a material. If the wave hit a defect, they bounce back and telling us exactly where the flaw is and how big it is. The tool that we use for ultrasonic testing is we use a flaw detector, a probe which is transducer, and a gel or oil as a couplet to help the sound travel. What we can find when we use ultrasonic testing is it is great for finding internal crack, well gaps, and corrosion thinning. So the benefit of the ultrasonic testing is it gives us result instantly, measure depth accurately, and unlike X-ray, it has no radiation risk.
Okay, for this slide, I will be talking about the radiographic testing, also known as RT. The radiographic testing is a non-destructive testing method that uses X-rays or gamma rays to inspect the internal structure of a material or component. The basic principle is that different materials and defects can absorb radiation differently, and because of this, defect inside the material can be captured as an image on a film or digital detector. In terms of equipment, RT requires a radiation source such as X-ray machine or gamma ray source, a radiographic film or digital imaging system, and also an image processing system to analyze the results. RT is mainly used to detect volumetric defects such as porosity, blowholes, and also the incomplete penetration, especially in welds. These defects are difficult to see from the surface but can be clearly identified using the radiographic image. And one of the major advantages of radiographic testing is that it's excellent visualization. And this it will provide a permanent record of inspection results and also allow the inspectors to clearly see the size and shape of internal defects. Next, this slide shows how non-destructive testing is applied in petrochemical industry. The first is pipeline inspection. The pipelines are inspected using ultrasonic testing and also radiographic testing to detect the corrosion, cracks, and also weld defects. Ultrasonic testing is especially effective because it can measure remaining wall thickness and also help to identify the internal corrosion. Second one is the weld inspection, where the welds in pressure vessels and pipelines are very critical for safety, and methods such as RT and UT are used to ensure proper fusion and penetration. And in addition, the MPI and DPT are used to detect surface breaking cracks that may not be visible to the naked eye. Lastly is corrosion monitoring. In petrochemical plants, corrosion under insulation and internal corrosion are major concerns. The ultrasonic thickness measurement are routinely carried out to monitor the corrosion rates and to help predict the remaining service life of equipment, and this will help to prevent the unexpected failures and also to ensure the plant safety. For this slide, I will explain the role of NDT in the shipbuilding industry. The first one is hull weld inspection. The hull welds are inspected using UT and RT to ensure structural integrity. And additionally, MPI and DPT are commonly used to detect surface cracks after welding, which is important to prevent future failures. Second is plate thickness measurement. The ultrasonic testing is widely used to measure plate thickness and detect the corrosion loss, especially in areas like ballast tanks and underwater hull sections where corrosion is more severe. The last application is fatigue crack detection. The ship will experience continuous cyclic loading due to waves and cargo movement, and over the time, this can cause fatigue cracks. NDT techniques such as UT and MPI will help detect these cracks at an early stage before they grow to more critical sizes and will compromise the ship's safety.
Next, I will explain about the comparison between ultrasonic testing and radiographic testing. For ultrasonic testing, It uses high frequency sound wave. It can detect internal cracks, lamination, and excellent for thickness measurement. It is also safe and suitable for in-service inspection. The data is numerical and signal interpretation, low cost, and best for corrosion monitoring and internal degradation. And for the radiography testing, it uses X-ray or gamma rays. It can detect porosity, slag inclusion, visualizing internal weld quality. It has radiation hazard, mostly used during fabrication or shutdown. And permanent radiographic image, it has higher cost, less portable, and best for quality control of critical welds. Next part is suggestion for improvement. The first is by combining the NDT methods. UT can be used for continuous monitoring of corrosion, while RT can be applied during fabrication or major shutdowns to verify weld quality. Next is by increasing inspection frequency. More frequent inspections enable timely maintenance actions and significantly reduce the risk of sudden failure. And third is automated and advanced ultrasonic testing. In petrochemical facilities, AUT allows for faster and more accurate inspection. In shipbuilding, automated UT systems are effective for scanning large welded areas of ship hulls. And last is implementation of preventive maintenance program. Preventive maintenance supported by regular NDT inspection leads to improved safety, reduced downtime, and lower maintenance costs. Conclusion: NDT is important to maintain the safety and quality in industries. Shipbuilding and petrochemical industries use NDT to perform the best quality and safety to the customers. The selection of the best NDT methods can perform the effective results with low cost. That's all from us. Thank you.